In this video, let's go ahead and apply our understanding of quadratic equations to see if we can find the value of two unknown integers together. In this problem, we're trying to find the value of two consecutive positive integers so that when we add them together, their sum of their squares is going to be 145. To begin, let's start by writing algebraic expressions that represent each of these integers. For the first integer, I'm just going to go ahead and use the variable n to represent it. For the second integer, if it's going to be consecutive to the first integer, that means it has to be right next to it, so we really have two options here. For one, we can write n plus 1, that could be one expression to represent a consecutive integer, or we can write the expression n minus 1. So no matter what, as long as n represents an integer, then n plus 1 will represent the integer that is consecutive and 1 larger than it, and n minus 1 will represent an integer as well that is 1 smaller than it. Now it's up to you which of these two expressions you want to use to represent that second integer, but my preference here is going to be using that n plus 1 for the second integer or the larger integer, and of course we're going to use n to represent that first integer or the smaller integer. So we now have our expressions for the first integer and the second integer, and they're consecutive because they're only separated by 1. And so let's go ahead and now talk about how to square each of these expressions. Now if we go ahead and square this expression of n over here, we're going to go ahead and take that n value, whatever the value of n is, we're going to raise it to the second power. That would be the first integer squared. And for that second expression, well, that's going to be this quantity of n plus 1. Again, that's that second integer, and we're going to go ahead and square that as well. So this right here is representing the squares of each of these integers. This is the first integer squared, and this is the second integer squared. Now let's talk about the word sum. Well, the word sum means we are adding two things. So if we go ahead and add this n squared plus this quantity of n plus 1 squared, that should equal this 145. Now if we go ahead and write this as an equation, we're going to have this n raised to the second power, plus we have this quantity of n plus 1 raised to the second power. That's the sum of those two integers, and this is going to equal this 145. Now squaring this n, that's going to be just n squared, because anytime you square something, it's going to be positive. Then I'm going to go ahead and actually write out this very detailed. I'm going to go ahead and expand this binomial. If you feel comfortable with this, feel free to skip ahead a little bit, but I'm just going to try to write more details than less. And then this is going to equal 145. All right, so next let's leave this n squared alone for now. Then let's go ahead and FOIL this out. So n times n, that's going to be n squared. Then we have n times 1, that's going to be 1n. Then we have 1 times n, that's another 1n. And then 1 times 1 is going to be 1. So we have n squared first. And then on the outers, we had a 1n, or just n. Then on the inners, we had another just n, and then 1 times 1 we said was 1, and this is equal to 145. All right, so we're cleaning this up a little bit, but I think we can go ahead and combine some like terms here. So if we combine this n squared and n squared, if we add their coefficients, that's going to be 2n squared. And then if we go ahead and combine this 1n and 1n, that's going to be plus 2n, okay? And then we have a plus 1, that's going to be a constant that's left alone right now, and then we have 145 on the right side. All right, slowly but surely, this equation is looking a little bit easier to work with. Now let's go ahead and just set this into standard form and set it equal to 0 so we can solve this quadratic equation. So we can subtract 145 from both sides of the equation. And when we do that, we're going to get the equation 2n squared plus this 2n minus 144, and that's going to be equal to 0. At this point, we have a quadratic equation in standard form, and so you can try to solve by square roots, or we could solve by factoring or completing the square or the quadratic formula. But if you notice that all three of these terms have a GCF of 2, it might be in your best interest to go ahead and factor that out so it becomes a little bit easier to solve. So we have 2 multiplied by the quantity of this n squared plus n minus 72 is going to be equal to 0. So hopefully when you look at this trinomial, it actually looks pretty nice to factor. If we go ahead and factor that, I think it's going to become n minus 8 and then n plus 9. So go ahead and pause if you need to think about that a little bit, but that should be the factored form for this trinomial. Okay. If we just take a look at this n minus 8, then what would make this linear binomial equal 0? Well, that would happen if n is equal to positive 8. And looking at this n plus 9, that binomial, if n was equal to negative 9, then this whole equation would equal 0 as well on the left side. All right, so now that we've done all this algebra, let's see what these two values of n equals 8 and n equals 9 really tell us. Well, let's take a look at possibility number 1 where n is equal to 8. So let's see what happens in this scenario. Remember that first integer was being represented by that expression of n, so if n is equal to 8, then this would just equal to 8. And for that second integer, that remember we said it was going to be that expression of n plus 1. So we substitute 8 in here, 8 plus 1 is going to be 9. So these would be our two values. Our two values here we're saying are going to be 8 and they're going to be 9. So if we do 8 and 9, are those consecutive positive integers? They are. If you want to say, well, what is this 8 raised to the second power? Well, 8 squared, that's going to be 64. If you take this 9 and you square it, that's going to be 9 squared, that's going to be 81. If you add this 64 and 81, you do get this 145. So this does check out nicely. Now what about possibility number 2? This is when n is equal to this negative 9. So let's check out and see what happens here. Again, that first integer is represented by n, so in case n is negative 9, then n would be negative 9 here. And in a second integer, it would be n plus 1. That would be negative 9 plus 1, which would be negative 8. Okay, so these two integers here of negative 9 and negative 8, they do, if you go ahead and square them and add them together, you do get 145, but try to remember what we were being asked in the first part. So I think we were being asked earlier that we are looking for two consecutive positive integers. So while this negative 8 and positive 8 do work mathematically, these are not actually the answers we are looking for because they are negative. All right, so these both pairs do work, however, one of the pairs doesn't actually fit what we're looking for. So while algebraically that n equals 8 does work when you substitute it in, and when n equals negative 9, it also works algebraically when you substitute it in, we ultimately have to go ahead and conclude that the two positive integers we're looking for are 8 and 9. And there you have an example where we went ahead and applied our understanding of quadratic equations to find the value of two unknown integers. If you found the video helpful, please consider giving it a thumbs up and letting me know in the comment section down below. And if you have a classmate or friend who might also find it helpful, please consider sharing it with them so it might help them as well. So as always, keep up the great work that you're already doing, and I'll see you in the next one.